function, which is this, and dy, which is the differential of y, and dy is f prime of x dx. So these are two different things. When we're asked to find the derivative, we find f prime. When we're asked to find the differential of the function, then we have to find f prime of x dx.
And that's because f prime of x equals dy over dx.
Exactly. Exactly. Okay, so now this is another formula or idea, if you want, that I would put on in my list of topics for from Calc 1. I will put this, f of x plus a little bit of error in x. This is what it means. Or f of x plus h is the same thing, right? So f of x plus a minor error in x, that's what dx is, or h is, or delta x is approximately f of x, the y value, plus a little bit of y, error in y, the differential of y, which is f prime of x dx. So whenever I want to determine the function value at an x plus or minus a tiny error, this is like determining the function value of x plus the differential, the error in y. So this is the y and this is the error in y. This is the x and this is the error in x. So f of x plus the error equals f of x, which is the y value, plus the error created in y. And then you will never forget this. So I have to find the function. Well, the function is obviously x to the 6th power. I have to find f prime, which is 6x to the 5th. I have to identify the x, which is definitely 0.01. And now all I have to do is just put everything together. So this is, and of course x, I forgot, x equals 1. So then this will be f of 1 plus f prime of 1 times 0.01. So when a minor error gets created in x, then the result is very close to, not equal to, but very close to the function value at that point plus the minor error in y created by a minor error in x. So f of 1 will be 1 plus f prime of 1 will be 6 times 0.01. So this is 6.06, so 1.06. Very elegant result. And you can check. You can put 1.01 and take it to the 6th power, which I'm sure you prefer 1.06 instead of taking 1.01 to the 6th power.
1.0615.
It has to be very close because the smaller delta x or dx or h, right, the closest will be because of the linearization. So if this is the function and this is the tangent, I can use the tangent to evaluate the function as long as I'm very, very close to x. I use the line, right? So if this is the function and this point, if I use the tangent to evaluate something here, not here, right? If I use the tangent to evaluate something very close to x, which is 1 in this case, it doesn't matter. The error is small. So if I use the function to evaluate this point at this point, or use the tangent because it's so close to this point, it doesn't matter. The error is, I shouldn't say it doesn't matter. The error is small. And I prefer this than using the function. Good. Next question. I hope to see some of you on Saturday if you'd like.
Yeah. Should we bring snacks?
Say it again.
Should we bring snacks?
Bring some food if you want to.
Are you gonna bring candy then?
Should I bring candy? Okay, I'll try.
What room is gonna be? It's gonna be here?
Yes.
11 to 12:30.
Now don't get upset because I invited everyone, meaning.
I'm pretty possessive. I get jealous.
No. It just means that I'm going to alternate. One problem for you and one problem from college algebra. One problem for you and then one for college algebra.
Oh, they're
If they don't come up quickly with questions, then I'll come back to you. But I will try to stay till I finish all your questions. Anything else?
Do we have a
Yes?
a practice final, like a old final?
Oh, I can post something if you would like.
That'd be nice.
I don't return final exams, so I can post something. But we don't return final exams. We keep them for, I don't know, 7 years or so.
Why?
I'm not really sure
Okay.
because, 3 years from now, somebody can say, "Oh, I think I got a better grade" or something, and so we keep them.
When are the grades finished? Like,
Oh, yeah.
will it be, when will we know what our grade is?
Oh, it's after the final exam.
Like the day after?
Yeah, yes, I have to turn in the final letter grade.
What's the last day for you to like submit the grade?
I have 24 hours normally after the final exam.
Oh, okay.
5 years.
Yeah.
What about slant asymptotes?
Yes, very good. Very good. What function has a slant asymptote?
Right.
Rational function. Which type? Excellent. Which type?
3.
Exactly. Only type 3, meaning the degree of the top must be
Smaller than. Bigger than.
Larger.
by
By 1.
why? Because when I divide, I have to get a line.
Okay, right.
So if I have degree 4 over degree 2 and I divide, I don't get a line.
Right.
If I have degree 3 over degree 2, yes. When I divide, the quotient will be a line. If I have degree 4 over degree 3, yes, the quotient will be a line. But if I have 4 and 4, the quotient will not be a line. I mean a slant.
You also do the limit of the derivative, and that's a number, is that also a slant asymptote?
So the limit of the derivative
Yeah.
to find the slant asymptote?
Yeah, doesn't that work also?
The limit of the derivative. That is the tangent, not the slant asymptote.
I mean, there's a limit of purchase infinity.
Yes, I agree with that.
That's what I mean.
Yes, but not the limit of the derivative.
Right. I meant
Correct.
the limit of purchase infinity.
Correct, but when you find the limit, you will only get infinity or negative infinity, and you will not get the slant asymptote. It's a very good point you're making.
But I think you could, because in the one, Mark, but like in the quiz we did, it had x plus natural log of x squared plus 1. And then if you get the
Very good. I was
going
gonna talk about that.
Approaches infinity, it's
Correct, but that is not a slant asymptote. You graphed it because you wanted it to. I was gonna tell them.
I thought it was.
No. No, a slant asymptote is only when we divide,
Okay.
not in a particular function. If there is no ratio, there is no slant asymptote.
Okay.
I have to determine the quotient, and there is no quotient there. You don't have top and bottom, and you cannot use. There is no function like natural log that has a slant asymptote.
Okay.
There are only rational functions and only type 3.
Gotcha.
No other function has a slant asymptote.
And so.
And that one was x plus natural log, so there is no discussion there. It's not a rational.
Right.
Agree.
And so it just matters like if it was.
So you can erase the slant asymptote. Thank you for reminding me.
Yeah. I was gonna come back.
No, please erase it. There is no slant asymptote there.
If it was like 5x cubed plus 1 over x squared,
Yes,
then the slant asymptote would be.
yes. Let's do that. No. So let's do it.
Okay.
Just come up with whatever.
5x cubed plus 1 over x squared.
I didn't realize that you stopped at x squared. Then the answer is yes. Because you have 5x cubed over x squared plus 1 over x squared, and then indeed the slant asymptote will be this. I thought something else was following here. So yes, the slant asymptote is y equals 5x, no question. So you don't need to divide because the denominator is just one term. So you are able to separate the fraction and you're done. But if you're not able to separate the fraction because the denominator has two terms or more, then you will have to use the long division.
Do that,
So, yeah, so let's do this.
Very good.
What happens to 1 over x squared?
Nothing. When x approaches infinity, that quantity goes to 0.
Oh, that's
So you wanna, if it's something like that, you just split it and then it's the first,
The quotient.
yeah.
Yes, this is the quotient, this is the remainder, this is the divisor. Only the quotient of the division is the slant asymptote. Okay, so let's come up with something else then.
5x cubed plus 1 over x squared plus 1.
Very good. So yes, that's true. The slant asymptote of this is not going to be 5x.
Right.
Good.
You can't just split.
We'll see in a moment what happens. So we divide 5x cubed. The term with x squared is missing. The term with x is missing. So plus 1. So then I'm dividing by x squared plus 1. X squared times what is 5x cubed, and I get 5x. I distribute. Where's my, I had red. Oh, here it is. So then 5x times x squared is 5x cubed, I subtract. 5x times 1 is negative 5x, and I subtract. And it happens in this case, that's what I said, let's see what happens, because I cannot continue the division. So let me change this a little bit. So let's say plus 4x squared minus 3x plus 2. Okay, so it happens that the quotient will still be 5x because I can no longer divide negative 5x by x squared. So that's why I changed the function. So let's start from scratch. Y equals 5x cubed plus 4x squared minus 3x plus 2 divided by x squared plus 1. This is a rational function. It is type 3. Degree is at the top is 3. Degree at the bottom is 2. The ratio will be 3 over 2, which means a line. So then, x squared plus 1, 5x cubed plus 4x squared minus 3x plus 2. So x squared times what is 5x cubed? Yes. So then 5x times x squared is 5x cubed, subtract. 5x times 1, 5x, subtract. Be very careful where you put it. These two go away, bring down the next in line. And this is negative 8x. And then x squared times what is 4x squared? It will come up. We can bring it down if you want. So 4 times x squared is 4x squared, and I subtract. And 4 times 1 is 4, and I subtract. So negative 8x and minus 2. You understand that I cannot continue because x squared goes into negative 8x? No. So the answer of this division, so then y can be rewritten as 5x plus 4 minus 8x plus 2 over x squared plus 1. This is the slant asymptote because this will eventually go to 0 when x approaches infinity. Why? Because this is type 2, right? The top is so much smaller, so much less powerful than the denominator, so when x approaches infinity, that fraction goes to 0. So now if I were to graph this function, I hope you're not going to ask me to do that. So then I will have to graph 5x plus 4, y equals 5x plus 4 first when x is 0. y is 4. And when y is 0, I have 4/5. So negative 4/5. So it's something here. So this will be the slant asymptote y equals 5x plus 4. And somehow the function has to follow it to negative infinity and to positive infinity.
I remember before we would say like y equals the limit of x goes to infinity.
No, it's y equals x. So the limit is x approaches a. So that function goes to infinity, right? Well, that's so in this case, a is x 5x plus 4.
I just remember I was saying for that step we were saying the remainder approaches to 0. I remember we used to write something to the x to infinity or something.
When we determine the slant asymptote?
Yes. Or make it clear.
Well, in the table, I will have to write negative infinity to infinity. So for this particular function, although I'm not going to determine any of this, I will write here, because it follows this slant asymptote, I will write here negative infinity, and here infinity, because the slant asymptote has a positive leading coefficient. So I know that the end behavior will be this, because the slant asymptote has a positive leading coefficient. But in general, so in this particular case, you don't have to write it, or you just say the limit of y as x approaches negative infinity is negative infinity, and this one positive infinity. But you can. So if you write limit of 5x plus 4 minus 8x plus 2 over x squared plus 1 as x approaches negative infinity, this will be 0, and this will be negative infinity, because it's the 5x. It has to follow the slant asymptote.
Right.
Yes. And we say, asymptotically. Anything else? If you redo all tests with solutions, you should have absolutely no difficulties.
But you will post a practice test just a little extra.
I will take a look. As I said, I'll do my best to find one.
Thank you.
Any questions?